We're going to start factoring in this, and I say start because it's something that we're going to be doing for a long time, at least a week, because what we're going to do is a lot of different things with factoring. Now, you've probably heard a factor before, and when we talk about the factor as a noun, we're just talking about the numbers, and usually it's a number, but it says individual component of a product. Whereas when I talk about two-factor, it's rewriting as an equivalent product. So as we get into example 1, exercise 1, we're just talking about how we could rewrite this prime number as a product of this is composite, I guess I should say, and we can rewrite this as the product of only prime numbers. So what I'm getting at is that you could rewrite 12 not just as 2 times 6, because 6 is not a prime number, but you could rewrite 6 as 2 times 3, and that's what we're looking for. The way some people teach this is they might tell you to rewrite this with a factor tree, that 2 times 6 gives you 12, and you continue to break down until you have nothing but prime numbers at the bottom. So I could show you, and you don't have to do 2 and 6. You could do 2 and 15, or I might do 5 and 6 on this problem. But then from 6, I would have 2 and 3. So even if you did 2 and 15, it's still going to be the same thing, because if you break down 15, it's 3 and 5. No matter what, you're going to have the same prime numbers at the bottom of your tree. And you can always check your work as well. And like I said, it doesn't really matter. 4 times 4 gives you 16, but neither of 4s are prime, so you would have 2 and 2 and 2 and 2. So one more thing is you don't have to write it the way I have been writing these numbers. You could also rewrite it as 2 to the 4th power. I could have rewritten this one over here as 2 squared times 3. Same thing with 36. I could rewrite this as 2 and 18, 2 and 9, and 9 breaks down as 3 and 3. So you could rewrite this as 2 times 2 times 3 times 3, or 2 squared times 3 squared. And the reason why this might be to your benefit is then we can get to factoring just binomials like this. And you can rewrite it just like I did these factor trees. 5 times x is the same thing as 5x, and then 5 times 2 gives me 10. The reason why I'm bringing this to your attention is when you have a common factor, you can actually bring that number that's common in front, and then the things I did not circle, the x and the 2, stay inside the parentheses. And this is how we can do what is called the greatest common factor, GCF. So if I can check my work because 5 times x is 5x and 5 times 2 is 10. So some of the problems I think are pretty straightforward. I know some people do this in their head. They just say, oh, 2 goes into both 2 and 6, and then they just ask themselves, 2 times x gives me 2x, and 2 times negative 3 would give me 6. Otherwise, you could rewrite it exactly like what I said. 2 times 3, circled pairs go in front. The numbers that are in common, I should say, go in front. But that might help you understand if I were to break this down. Now, you want the greatest number that goes into both, so the 3 and the 2, and then the 3 and the 5. So if you do the problem the way I mentioned, you can just bring the 3 in front. Nothing else is in common. Don't forget about the x that was in the problem, so 2x plus 5. Same thing with the next one. 2 times 3, and again, I'm well aware that people just guess and check. 2 times 3 gives you 6, and 2 times 7 gives you 14, so you're left with 3 minus 7x. And as you get more practice, I hope you don't have to show as much work. Sometimes we also have letters that are common. But if you do the problem the same way I just said, 3 times x, and then 3 times 2 times x, you can do the problem the same way. That the 3 and the x are what's in common, so we can write that in front, and then my leftovers would be x and 2. And you can check your work, because if you distribute 3x into the problem, you'll get back to the original problem. So I can do this next one the same way, 5 times 4. Now you'll notice I'm not going to greatest common factor everything, because, if I consider 5 times x, nothing else would be in common besides the 5 and the x. So 5x, in parentheses then, you still have a 4 minus x. As I move on to the next one, which I need to leave some space here so you can still see the next problem. There's a 5 times 2. There's 2 x's there. 25 is 5 times 5. So we have an x and a 5 that's in common, an x and a 5. So we write that in front, and we're left with 2x plus 5. And like I said, we want the greatest common factor. So as I look at the next one, there's a lot of numbers that are like between 30 and 20. The biggest number would be 10. And then 10 times 2 will give me that 20. Notice that this time there's no common x's. Well, that's okay. We can still do the problem the same way. 3x squared and minus 2. So as I look at the next problem, now notice it doesn't necessarily have to be the greatest common factor. So one option, I'm just realizing that there's more than one way of doing this, is you can distribute all of these problems in here and see if you get the same answer. So number 1's wrong because 2x times 15 is not 36. As I'm looking at the next one, that doesn't look like a bad option. This option 3 looks bad because 5x times 7 is 35. And well, this one looks bad to me because 9x times x is not 9x squared. But the official way of doing this, now that we see the correct answers are already option 2, would be if you look for the greatest common factor. So 4 times 5 gives me 20, and 4 times 9 gives me 36. This first term had 2 x's. This one just had 1. I don't really like how bright that color is, but you have a 4 and an x that's in common, so you write that in front. And then the leftovers of 5x minus 9, and that matches perfectly to this. So now what we're going to do is look for our greatest common factor for a trinomial. Okay, so that's all I want you to practice here. We can have 3 terms, and you just want to make sure that there is a common number that goes into each. And this first one is as simple as 2 goes into each. So we want to factor that out. X squared plus 4x plus 5. And if you have any questions, I would encourage you to write them down and come to class with them. Same thing with the next one. 5 times 2, 5 times 4. And, well, that one's just a 5, but I also tell students to write down 5 times 1 at times. I know I didn't do that over here. But the reason why I would encourage that is some students will forget to write down that 1, and then they'll just ignore it. They won't write down plus 1. So if you didn't write that plus 1 and you went to check your work, you wouldn't have a 5 times 1 to put right here and get the same answer. So that's why I encourage students to do that. Same thing with the next one, except the next one, if you notice, there are 3 x's here. There's 2 x's, and then there's 1 x. So we do have a common x to move in front as well. But then, besides that would be 4 times 2, 4 times 3, and then 4 times 5. 4s. So we can move that 4x in front. You're left with 2x squared, because remember I took one of those 3 x's out, minus 3x plus 5. And check your work. Distribute in, see if you get the same thing. And then same thing with the next one. And as you get practice, I hope you can do this in your head. It's not a big deal if you can't yet, but it would be nice if you got there. So as I move on to the next one, remember we talked about this pattern of x minus a, x plus a. When we multiplied it together, we got what is called the difference of squares. I don't say difference of perfect squares, but that's nice that he says perfect squares. It's just the difference of squares. So we noticed a pattern in the previous section. So when we get to factoring, notice that there is no greatest common factor. But if you can identify that you have a minus, that's why we call it a difference, with two perfect squares, x times x and 3 times 3, get used to writing this answer as x minus 3 and x plus 3. And that is your final answer to letter A. So again, sometimes what I'll do is I'll point out that there's no greatest common factor, but then sometimes I'll just tell students, if it's a minus, which it is, 2 times 2 gives me 4, x times x gives me x squared. To make it negative, make one minus, make one plus. Now, if you get stumped on the next one, I understand, but it is still a difference of squares, because you could rewrite that first one as 2x times 2x, and the second one is 5 times 5. So 2x minus 5, 2x plus 5. If you don't believe me that this works, FOIL it out and see you get the same answer. So hopefully you get some good practice with this last one. Except this last one, well, I think this last one, this is all we needed to come up with. Whoops. And we can also do all of that with fractions. Don't be scared, because you can just think of each piece the same way. X times x, 1 times 1, and 2 times 2. So as long as you have a difference, which we do, a minus, you can just rewrite each piece the way it is. X minus 1/2, x plus 1/2. Look at the next one. 5 times 5, x times x, 3 times 3. So it's got to be 5 minus x over 3, and 5 plus x over 3. By the way, multiplication is commutative, so if you swap these two, the minus and the plus, you are still correct. The order in which you write it does not matter. So before you freak out about the next one, remember 2 times 2 gives you 4, 9 times 9 gives you 81, x times x gives you x squared, 7 times 7 gives you 49, 3 times 3 gives you 9, and then you just have to write the other one with a plus. And if you look at the last one, more of the same thing. Don't be scared. 6x minus 7y, and then 6x plus 7y. And when we get to factoring, sometimes we might have to do a combination of a greatest common factor and a difference of squares. So just start with the GCF first. So as I take out the 5 in this first problem, that's why I would advise you to really do these problems pretty quickly. But then from here, notice that you have x times x and 2 times 2 with a minus. The 5 still has to be part of the problem. And then we have x minus 2, x plus 2. That's it. We're just going to be combining things together. So if you look at the next one, greatest common factor out is 7. And don't forget that 2x times 2x, but also 1 times 1. That is a difference of squares. The 7 is still part of your answer, but then you have to write out 2x minus 1, 2x plus 1. I'm running out of time, so I'm going to hurry through these last couple. Let's see, not just a 10, well, let's just do 10. And then 4 minus 25x squared. So that 10 is still there. 2 minus 5x, 2 plus 5x. And then the last one is also a bit tricky, because not only do we have to factor out a 3, but we have to factor out an x. And then we're left with x squared minus 16. So your final answer is 3x, x minus 4, x plus 4, and you should be ready for the homework.